Myself is Dr. G. Venkat Subbareddy, Associate Professor of Tribal Department. Associate Professor of Tribal Department. Today topic is overhead line insulators. Overhead line insulators. Overhead line conductors should be supported on poles or towers in such way that currents from the conductor do not flow to the earth through the supports. That is, line conductor must be properly insulated from the supports. This is achieved by securing the line conductor to support with the help of insulators. The insulators provide the necessary of insulation between the line conductors and support, thus prevent any leakage current from the conductor to earth. That is nothing but overhead line insulator. The main purpose of the insulator is to avoid any leakage current from conductor to earth. Overhead line insulators. The insulators for overhead line provided insulation to the power conductor from the ground. The insulators are connected to the cross arm of the tower and the power conductor passes through the clamp of insulator. To the clamp of insulator. What are the properties of insulators? Properties of insulators. One is nothing but high mechanical strength. The second one is a high electrical strength. The third one is a high insulation resistance, free from impurities and moisture, air and gas free. Withstand on the flashover phenomena. Withstand the flashover phenomena. It must be strong enough to carry the tension and weight of the conductors. It must have high dielectric stress to withstand the voltage stress in high voltage system. It must possess high insulation resistance to prevent the leakage current to the earth. The insulating material must be free from unwanted impurities. It should be not phosphorus. There must there must not be entrance on the surface of electrical insulator so that moisture or gases can enter in it. The physical as well as electrical properties must less affected by changing the temperature. This is important. The physical as well as electrical properties must less affected by the temperature also. Withstand with flashover phenomena. The major types of insulators are normally used type of insulators are one is nothing but a pin type insulator. The second one is a suspension type insulator. The third one is a strain insulator. Fourth one is a cycle insulator. The pin type insulator is used only up to 33 kV. Beyond 33 kV, the pin type insulator is so bulky and uneconomical. Suspension type insulator. In case of suspension type insulator, the insulator voltage is 11 kV. Number of discs is connected in the form of a string. Then we get the suspension type insulator. Strain insulator. Strain insulator can be used at dead end of the tower or crossed area where high electrical stress is subjected. High stress is subjected, then go for strain insulator. Cycle insulator. Strain insulator act as a cycle insulator for low voltage. For low voltage. First one is a pin type insulator. Pin type insulator consists of single or multiple units. They are used only up to 33 kV. By high voltages, the pin type insulators are very heavy and more costly. The size of insulator will be so bulky beyond the 33 kV. Then for this is nothing but diagram of the pin type insulator. This are the one insulator. This can be used as a up to 33 kV. These are the construction of the insulator, groove of the conductor, sheets or petticoat, cementing, and galvanized steel pump. This is the diagram for pin type insulator. A pin type insulator consisting non-conducting materials such as porcelain, glass, plastic, and polymer or wood. As the name suggests, the pin-type insulator is secured to the crossarm on the pole. There is a groove on the upper end and the insulator for hosting the conductor. The conductor passes through this groove and bound the annealing wire for the same material as a conductor. Pin-type insulators used for transmission and distribution of electric power up to 33 kV. Beyond the 33 kV, pin-type insulators are so bulky and hence uneconomical. Suspension insulator. A suspension insulator consists of a porcelain disc units mounted one above each other. Each disc is provided with metal cap at the top and a metal pin under. A string of any number of units can be built according to the line operating voltage. The conductor is suspended below at the point of the support by means of a insulator string. These are the three insulator disc idi. At the bottom is nothing but conductor, at the top is nothing but cross arm. The number of disc in a string string depends upon the line voltage and atmospheric conditions. A conductor is suspended at the bottom of the end of the string, while other end of the string is secured for cross arm of the tower. Each unit or disc is designed for low voltage, say 11 kV. The number of discs in series is obtained depending upon the working voltage. For instance, if the working voltage is 66 kV, 6 discs are connected in series by providing in the form of a string. For higher voltage greater than 33 kV, it is usually practiced to use suspension type insulator consists of number of porcelain discs connected in series by metal link in the form of a string. The conductor is suspended at the bottom end on the string while the other end of the string is secured for the cross arm of the tower. Each unit of disk is designed for low voltage, say 11 kV. The number of discs in series would obviously depends upon the working voltage. For instance, if the working voltage is 66 kV, then normally 6 DCs are connected in series while providing the string. This is nothing but a diagram for suspension type insulators. Advantages of suspension type insulator. Suspension type insulator are cheaper than pin type insulator for voltages more than 33 kV. For 33 kV, three discs are connected in the form of a string. Each unit of disc of suspension insulator is designed for low voltage, usually up to 11 kV. Depending upon the working voltage, the desired number of discs can be connected in the form of a string. If any one of the disc is damaged, the whole string does not become useless because damaged string can be replaced by sound one. The suspension arrangement provides greater flexibility of the line. The connection of the cross arm is such that the insulator is a free to swing in any direction that can be take up a position where mechanical stress is minimum. In case of increased demand of a transmission line, it is found more satisfactory to supply the greater demand by raising the line voltage than providing another set of conditions. Additional insulation is required for raised voltage can easily obtain the suspension arrangement by adding the number of discs in series. Strain insulator. The strain insulator is used for high stress insulator at the curved area at the end of the tower. There is a special mechanical strong suspension insulator. These are used to take up the tension at the conductor on the line terminals, the angle towers at road crossing. These strings are placed in horizontal plane. The two or three strings of insulator in parallel can be used when the tension of the conductor is very high. Tension is high, then go for strain type insulators. Where there is a dead end of the line or there is a corner shape, the line is subjected to greater tension. In order to relieve the line of excessive tension, the strain insulators are used. However, for high voltage transmission line, strain insulator consists of an assembly of suspension insulators as shown in the below figure. The disc of strain insulators are used in vertical plane. When the tension in the lines exceedingly high, the long reverse span, two or more insulators are used in parallel. This is nothing but diagram for strain insulator. This is nothing but diagram for strain insulator. This is a high stressed insulator. Whenever the line is subjected to high stress, then go for strain insulators as a suspension insulator. The one more type of insulator is cycle type insulators. The cycle type insulators are used as a strain type insulator for low voltages. For low voltage application, the cycle type insulators are most suitable. In earlier days, the cycle insulators were used as a strain insulator. But nowadays, there are free used for low voltage distribution line. This can be used for low voltage systems. Such insulators can be used either in horizontal position or in vertical position. This can be used either horizontal or vertical position. This can be directly fixed at the pole or a bolt or to the cross arm. This is a diagram for strain type insulator, cycle type insulator. This is nothing but a pole. This is a bolt is fixed to the cycle type insulator. This is a D sharp. This is a fixed to the pole, directly fixed to the pole. Next, potential distribution is suspension of insulator. In case of over the suspension type insulator, the voltage across each insulator is not uniform because the presence of shunt capacitance, the voltage across each insulator will be different. In this diagram, we will consider three insulated string. Every portion is between the two bolt. Then every porcelain factor act as a one capacitor. That capacitor is known as a self capacitance or mutual capacitance. One more capacitance that is exist between the cross arm to the metal structure, that capacitance is known as a shunt capacitance. Due to the presence of C1, that is shunt capacitance, the voltage across the every unit is not uniform. The voltage across the conductor nearer voltage across the insulator nearest to the conductor which has a more voltage, we move from the conductor to tower, then voltage goes on decreasing, then V3 is greater than V2 and V2 is greater than V1. That means voltage across the conductor, voltage across the insulator nearest to the conductor will has a more voltage. Voltage across the tower, across the insulator nearest to the tower will be minimum voltage. A string of suspension insulators consists of a number of porcelain discs connected inside through a metal links. Three disc insulator as shown in the above figure, three discs of insulator. The porcelain portion of each disc in between the two metal links, therefore each disc form a capacitor. This is known as a mutual capacitance or self capacitance. If there were mutual capacitance alone, the charging current would have been the same through all the discs. Consequently, voltage across the unit will have been same V by 3. However, in actual practice, the capacitance also exists between the metal fitting of each disc and the tower or earth. There is known as a shunt capacitance C1. Due to the shunt capacitance, the charging current is not same through all the discs of the string. Because of the presence of shunt capacitance, the voltage across each disc will be different. Voltage across each disc will be different. The disc nearest to the line conductor will has a maximum voltage and V3 is much greater than of V2 and V1. The following point is important. The voltage impressed on the string of suspension insulator does not distribute itself uniformly across the individual disc due to the presence of shunt capacitance. One more important point, the disc is nearest to the conductor as the maximum voltage across it. As we move toward the cross arm, the voltage across each disc goes on decreasing. One more important term related to the string efficiency, that is nothing but one more important term is string efficiency. String efficiency is defined as the ratio of voltage across the whole string, that is V, to the product of number of discs and the voltage across the disc nearest to the conductor is known as a string efficiency. That is, string efficiency is defined as voltage across the string divided by number of insulators into voltage across the disc nearest to the conductor. N is nothing but a number of discs in the string. This is a one more important term, that is nothing but string efficiency. Then mathematical expression how V3 is greater than V2 and V3 is greater than 1. For that reason, for mechanical expression, mathematical expression, we consider three disc of insulator V3, V2, V1. C is nothing but a shunt capacitance. C1 is nothing but a shunt capacitance, self or shunt capacitance. By applying the Kirchhoff current law, V2 is equal to V1 into 1 plus 1. V2 is greater than V1 and V3 is greater than V2. V3 is greater than V2. Then voltage across the top unit, second, everything will be calculated by using the finally the percentage of string efficiency, voltage across the string into N, the voltage across the disk nearest to the conductor. These are already discussed. Now, one more important topic, methods of improving of string efficiency. The string efficiency is improved by using three methods. By using the longer cross arm, the second one grading of the insulator, by third one is girding. In case of the disc insulator, one is nothing but shunt capacitance, and the one is shunt capacitance, another one is a self capacitance. Line is at the bottom end, cross arm is at top end. The potential distribution in the string of suspension insulator is non-uniform. The maximum voltage appears across the insulator nearest to the line conductor and decreases progressively as the cross arm is approached. If the insulation is the highest stress insulator breakdown or flashover takes place, the breakdown of other units will take place in succession. These necessities to equalize the voltage potential across the various units of the string, that is to improve the string efficiency by using longer cross-arm. The value of string efficiency depends upon the value of K, that is ratio of shunt capacitance to the mutual capacitance. Lesser value of K is the greater the string efficiency and more uniform in voltage distribution. The value of K is decreased by reducing the shunt capacitance. In order to reducing the shunt capacitance, the distance of the conductor from the tower must be increasing. That is nothing but a longer crosser. This is a one method for increasing the string efficiency by using the longer crosser. The second method is by grading of the insulators. In this method, insulators are different dimensions are chosen that each has a different capacitance. The insulators are capable capacitance graded. They are assembled in the string in such way that top unit has a minimum capacitance by increasing progressively to the bottom unit that is nearest to the conductor is reached. Since voltage is inversely proportional to capacitance, in this method tends to equalize the potential distribution across the in string. This method has disadvantage that large number of different sized insulators are required. That is nothing but by using grading. Another method is by using a metallic ring which is connected from the conductor to the surrounding bottom of the insulators. C is nothing but set capacitance. One more capacitance exists between the God ring to the metal link, that is equal to C2. The current flowing to the shunt path I1 is equal to I1 dash and I2 is equal to I2 dash. Then the current flowing to the C1 and C2 is equal to 1 I, that is nothing but uniform current. Then string efficiency increases. The potential across each unit in a string is equalized by using the God ring, which is a metal ring electrically connected to the conductor and the surrounding bottom of the insulator as shown in the above figure. The God ring introduced the capacitance between the metal fitting and the line capacitance. The God ring is connected in such way that the shunt capacitance current I1 I1 and I2 etc. equal to the metal fitting capacitance of I1 dash I2 dash. The resultant is same charging current I flows through the each string. Then consequently there will be uniform potential distribution across the string. Some important point relating to the insulators while solving the problem related to string efficiency. Some important point: maximum voltage appear across the disc nearest to the conductor, that is line conductor. Voltage across the string equal to the base voltage. Then the line voltage equal to root 3 into base voltage. Then stop here.